Hello, I'm Michał Skoczylas. I'm front-end developer, and I work with a team as a front-end technical lead. I'm responsible for JavaScript-related solutions. So that's me. Hello. And my work. I work with a company that operates in real estate business, and this company owns two major real estate websites in Poland, which is rynekpierwotny.pl and gethome.pl. You should definitely check this out. What I'm going to talk about today is our technological approach. So from our technological approach, we are focused on two things. First is user experience, and we handle this user experience with our single page application. And the second thing is search engine optimization. And to make that work, we moved our single page application to the server, and we have server-side rendering. So those two elements introduce new concept, which we are going to talk about today, and that is universal programming. So here we have. What is universal programming? Some people may reference this universal programming as isomorphic programming, but I will use the first term. Well, universal programming is basically when you have your code written in one place and you can run this code in two different environments. So for instance, you can write this once in JavaScript and run this on your server and in your browser. What that gives us is basically less potential places to make an error. Because if you have one implementation, that's easier to reason about this implementation. In the contrary, when we didn't have universal programming, we basically had the same logic written in two different environments, usually in different code bases. Those different code bases meant that we implemented that logic in two different languages for different environments. And usually, that logic was implemented by different developers with different experience. And if you have one logic in two places with so many differences, that's obvious that when the time comes and you have to change something, you have to evolve your application, you will encounter some problems. That's why basically universal programming means safety. And this presentation will not be about the technology stack. I will show you some examples with React and Redux, but only to show you the context, because I need to show you some examples. But otherwise, you can use any framework you like. You can use React, Angular, Vue, or any other framework you want. This presentation will be instead about the idea of universal architecture. So let's begin our journey. Let's begin with a question of how would you like to move your client application? Suppose you have your client application written in React and Redux for the sake of argument, and you want to move this application to the server side. The most important problem would be definitely to fetch your data, because when you have your application written in React, the place where you fetch your data is usually your lifecycle methods or recently hooks. But from the server perspective, there is no such thing as lifecycle methods, because server does not mount anything, it just renders. So you have no good place to fetch your data when you fetch your data in components. So the first problem is, how would you like to pick those functions from components and run them on server? The second problem is that even though you could somehow possibly fetch those data, you wouldn't really know which component will be rendered, because when you have your component tree, Some components may depend on state change, or some components may be rendered when you fetch some data and you compare with something. So at the very beginning, when you want to render your component tree without the data, you will have a problem because you don't know for which component you need the data to be fetched. And there are some possible solutions. We have some frameworks, we have some libraries that introduce which introduce some idea how to handle this problem. And you basically have different requirements from those frameworks. For example, you have to divide your views into different files. And next to those files, you have to keep your data fetching functions. So when you end up in this file, you first fetch some data and then provide that data to the component which is your view. So the first problem is that you have to rearrange your application. You cannot simply take your application and put it into the server. You have to rearrange your routing. And the thing with routing is that it also introduces file structure-based routing. Because when you have some request path, you have to map it into your file structure, and only then you can decide which file you can pick. So you have this file system-based routing with your views to render. And of course, that is problematic because you cannot use your custom router as you wish and forget about routes inside deep components, deep in your component tree. That may be also difficult to introduce to your application some other third-party dependencies like Redux. And that's just because you have some specific abstraction that requires something from your dependencies, and you may not be able to easily meet those dependencies. So the summary is that you don't have easy pick solution for this problem, how to move your client-side application to the server. And if you can do this, you basically have to adjust your application. You can't take your application and move it to the server. You have to adjust to meet those requirements. So maybe we can just think about different solution. We can think about server first approach, because when I think about moving your client application to the server, I believe that we may made some mistakes because we have all this experience with our client-side application. We have all this experience with React and how to fetch data inside components. And we could be basically a little bit biased by that thinking. That architecture that I introduced before could be a little bit biased by client-side approach. And what I'm going to propose right now is to take a step back and look at this from the other angle. So basically, what I want you to do is to think about all the different experiences with server web applications, because we have that in the history. We have PHP, we have Python, we have many different frameworks based on many different languages. So we have this experience, and we know that existed way before Node.js appeared. So we just have to try to understand how that works and design our architecture for React just based on this experience. So one simple design pattern is called Model View Controller, MVC. You have heard of it, but I don't want to move into this specific implementation of this design pattern, the thing that is very interesting for me is the separation of concerns, because you don't have to define your logic as a controller, model, or view, but that may be easy, but that's not the point. The point is that you separate the logic accordingly. So let's think about this MVC approach and how that should be handled. So when we have our controller, that is the logic that handles our request. It gets a request. From this request, we can get a path, and this path means that we have to do something for this view. We have to prepare some data. We have to render some view for this specific path. So we take the path, and using our model, we fetch the data. So we basically want, based on our path, fetch data accordingly and send it back to the controllers. The controller has the data ready, all data needed for this path. And when we have the data, we can pass it to the view. So view now could be our templating system. Basically, that could be anything. And what it does is that takes the data we have taken before and renders HTML. Then we take this HTML and our controller sends the HTTP response. So we know how it works, and now we should think about how to implement our React application. So at the very first, we forgot about our React implementation because we wanted server-first approach. Now we remind ourselves back about React and try to construct this whole React application within our approach. So as you see right now, first we just prepare our request. In this example, I show you React with Redux because that just is easier to show you this example, but that could be basically anything. You can use Mobix, you can use Simple State, you can use anything you want, but we'll stay with Redux for now. So we create a store. Store is a simple place when you can keep your data. And then you, of course, have to use your model to fetch data. The model could be some action that fetches data from API, or that could be a definition of database, and that could be some cache, or simply some calculation of data. So first you fetch data, and I call this logic data fetcher. You dispatch because this is Redux, and you await for the data to be fetched. Then, when you have the data in your store, you provide the data to your application. So your application has the data, and we use our React as a presentation layer. So it takes only data and use this pure functions, this pure render functions to simply gives us back our HTML. So we use our render to string function, which is basically React API for server-side rendering, and then we have to wrap it into some HTML. We need some header, we need some meta tags, and send it back as a HTTP response. So the main two elements of this logic, this solution, are data fetcher and our view. So let's start with data fetcher. Data fetcher, as you saw, is completely independent logic. It's just logic unrelated to components, because what we need from the server perspective is only data. We have to fetch data first, and then we'll think about this later, what will happen to the data. So it doesn't, it's not something that has to be combined with components. It doesn't have to be combined with your React application. It's just something that fetches data for a specific path. So this implementation allows you to explicit prioritize routes with a strong regular expression, because you can implement those routes into some map, and this map is from path to fetch to actions you want to trigger. And you can prioritize by very distinguished regular expression. You can even distinguish between numerical slack and alphanumerical slack and trigger different actions for that. So that's a very powerful tool. And I want to show you also the thing with application path. I would really recommend to use single file for your application path, because when you have that, you can use that one definition for your data fetching, for your rendering, and for all your links. And that's your advantage, because when something changes, when you have to delete something, you just go right into this one single place, and you have other places marked to show that you have this change. So this one single point of truth for routing is very useful, very convenient. And as you see, this fetch routes map is the core of our data fetcher logic, because data fetcher is simply a function that takes some path and triggers the actions and awaits for the data to be sent back to our controller. The second part is React and our presentation layer. Speaking about React from the server perspective, we have to acknowledge that we only use pure functions. We only use pure components. And that's basically what React is all about. It's all about declaration. You want to create pure components, pure functions, which take some data and render HTML. Because that's the declarative paradigm that React strongly encourages. So that's great, because we basically need our presentation layer to work like this. The second thing is that with this approach, you can simply use any routing you want. I would definitely recommend React Router, because it just feels so nice, so beautifully combined with React. Because what React is pure components, declaration paradigm. And when you have your components that could render your routes, which is React Router, basically, you have everything you need. You can create the whole application to work from this one element, and everything that works behind it, all routing, is just pure components. So that's great. That's very important that you can use that kind of library. Other thing is that you shouldn't basically consider fetching data from your components like this is a good choice, because I'm not talking in general. I'm talking about server-side perspective, because remember, we design our solution server first. So we only know server for now. And you wouldn't really expect your presentation layer to fetch data for itself. You want this data to be fetched beforehand. So that makes sense that you have your data fetcher that fetches the data for your components and then provide it in one go to render itself without any additional fetches. And why did we actually started to fetch data in React components? Well, I think that's because we had, because React was designed for browser too. And in browser, we have interaction. And that interaction basically needs some state, because that could something be input inside the state. We could change, we can switch something. And that's why we needed state in our React component. But then we went a step too further, and step too far, and we found that we can fetch data to our component state. And I would say that from the server-side perspective, that doesn't make much sense. As I said, you have data fetcher, but I would recommend that you fetch your data only for components which are actually displayed only in your browser, because that's some kind of component state if you think about this. Because when when it only lives in the browser, it's basically a part of the component, because the component just has to fetch the data for itself. So when we design our solution server first, we embrace two major design patterns. First, there's a React declarative paradigm, which is just how React was designed. And the second one is separation of concerns. We separate our data fetching and we separate it from our view, our rendering. So previously we had a problem moving our client-side application to the server. Let's try to go the other way around. So we have to understand the difference between client and server. Server is some kind synchronous, because we fetch data, we await for it, and then we render components and then go to the response. But client, in the contrary, is very different. It has fetching data, rendering components in the circle, because some interaction can trigger fetching data again and then rendering again. So you have the circle, this life cycle. That's why we have life cycle in the components, and it's only for client. So this approach in client has to fetch some data, because that's the most important part. When we have the data in our application will simply render itself, because that's what our application does. We have the application for client side, so it just renders itself. The only question we have to answer is where and when to fetch our data. So basically, that's quite easy, because we have to fetch data on every path change, because when path changes, we may end up with different data. And I show you right now a simple concept of higher order component, which is basically a wrapper for your application. And what you see right now is the simple logic, really one-liner, is a simple logic where you fetch your data, or you trigger your data fetcher only when your location changes, because we are in the browser, we have location. So that's very easy, because that's only one thing you have to add to your application. And when you wrap your application, it's not that you have to change something in your application. You just add it to your application around, and that's safe, because this component did mount will never trigger on server, so it's quite safe on both environments. And the conclusion is that well-designed architecture should provide you with painless migration. If you have some architecture designed, if you have something and you introduce this to a new environment, that shouldn't be very painless. That shouldn't require from you a lot of adjustments to make before. So why universal code is simple? Well, first, I think that we have to know that sometimes you have to simply try design your architecture differently. You have to try from the other perspective. For me, server-side rendering should be based on server-first design, because that brings you a lot of advantages. And the universal code is simple, because I think you have already your application written in universal code. Your application could be moved to the server side and run without any further additions to this application. That is universal code already. Some libraries or frameworks usually implement some complex logic for us not to bother and to not to make silly mistakes, and that's good. But I think that server rendering of your application is not really that complex logic, and you can implement it very quickly and easily without silly mistakes. The last thing I want you to remember is that when you move your application from the client to the server, you're no longer only front-end developer. You basically are a backend developer. And for that instance, you have to understand your decision, you have to learn your implementation, and you definitely have to know your design. Thank you.